video is on power for your work energy and power unit. First thing is the definition of power. It is defined as the rate at which work is done. Rate at which work is done. It is also defined as rate of energy transfer by any method. The equation for power, it equals work over the change in time. The work over the change in time. So what you're going to see from that is FD cosine theta over delta t, which really what you can see from that is FV, F times V for power. So there are many different ways that it can break down. The units for power are watts, which is just a capital W, and a watt is equal to a joule per second. So an alternative equation that we just now looked at here is going to be power equals force times velocity. This comes from power equaling work over time, which equals FD over T. I'm just paraphrasing, which equals FV, right? Because D over T is velocity. So think of it this way when it comes to your relationship between your variables. A machine which is strong enough to apply a big force to cause a displacement in a small amount of time is a powerful machine. So power and force are directly related, whereas time is indirectly related. Because if you would rearrange the equation, it would say delta T P equals W. Or in other words, delta T P equals F times D. Okay? So with that in mind, horsepower is an alternative unit that we're going to look for. There's really no abbreviation for that, but the equivalence is 1 horsepower equals 746 watts. So this is just an example of a 505 Corvette engine, 505 horsepower. That is a ton of watts. 746 times 505, wow, get up and go, right? Okay, so here's your sample problem. It says a 193 kilogram curtain needs to be raised 7.5 meters at a constant speed and as close to 5.0 seconds as possible. The power ratings for the 3 machines are 1, 3.5, and 5.5 kilowatts respectively. So which motor would be best for the job? So you also know that you're raising this thing, so we need 9.81 meters per second squared. We're going to solve for power. Technically, we're going to solve for power in kilowatts so that we can choose which motor would be the most appropriate. So our original equation is power equals work over change in time, where we need to break that down into FD over delta T. Technically, you would want to throw in your cosine theta here, whereas your theta would equal 0 degrees because your force and displacement are parallel to each other. Which your force is force of gravity, so m times g times d times cosine theta, all over delta t. So that is going to give you 193 times 98.1 times 7.5 times the cosine of 0. All of that divided by 5.0. So please take a second and put that in your calculators, guys. 193 times 9.81 times 7.5, cosine of 0 is 1, divided by 5 equals. Your calculator should read out 2839.9. Now that's in watts, guys. So that would be 2.8399 kilowatts. Agreed? So the final answer here, your power is going to be, looking at your sig figs, 2.8 kilowatts. Therefore, the motor that you would want to choose is the 3.5 kilowatt motor. Make sense? Okay, so that wraps up your work energy and power notes. Please work on your power worksheet at this time.